ladies and gentlemen. Today we are going to look at one of the main aspects of the navigation, where the direction device on board ships, which is fitted, the gyro compass, if it malfunctions, what is to be done? Almost all ships are fitted with a direction device, the gyro compass, which indicate the true north and also various courses to be steered by the ship. And it is one of the paramount navigation equipment on board all ships. Modern ships are fitted with 2 gyros or sometimes seldom one, and cross-checking the correct functionality of this particular primary navigation equipment rests on the shoulders of the deck officers of the ship. Coastal ships, while navigating, they have facility to check the gyro compass by using the transit facilities in various harbors. However, the ocean-going ships have to cross-check only by either reciprocal bearing with the known ships who have already determined their gyro error, or comparison of 2 gyros which are fitted on board ship, or by observing the rising setting azimuth of the sun, you can verify the functionality of the gyro compass. And to look at it, the rising setting of the sun, let us quickly look at the true motions. We are all aware Earth spins on its axis from west to east, and because of that, all celestial bodies describe motion apparently from east to west. And celestial body, in particular the sun, moves along the declination circle around the celestial pole. The sun appears to rise in the east, move westward, gaining an altitude till it reaches the ship's meridian overhead, and decrease its altitude till it sets in the west. And here I have shown you 3 pictures. One is, it is for understanding. If you are at the North Pole, you will find the celestial body will become a circumpolar body. That means all celestial bodies which are above your horizon will appear to describe a declination circle above you with a constant altitude. If you come to the equator, second picture, you will see all celestial bodies are rising in the east perpendicular to the horizon and set in the west. But we neither operate at the pole nor at the equator all the time. We are going to be operating intermediate latitude. If that is the case, we have to know the ship's latitude and sun's declination, and it has a solid relationship. Let us look at that. The sun, which is above the horizon, we call it as a day. When it goes below the horizon, we call it a night. Declination of the sun varies between 23.5 degrees north to 23.5 degrees south, which we are aware as summer solstice and winter solstice. When the sun declination is north and the observer, the ship is in the northern latitude, sun will remain above the celestial horizon for more than 12 hours. And for less than 12 hours, if observer were in southern latitude. And to sum it up, this particular theory, for sun to rise and set, your latitude, the ship's latitude and sun declination, when added up, it has to be less than 90 degrees. For the sun to be visible for 24 hours, we call it as a circumpolar body. If your latitude and sun declination are both the same name, both are in the north, added up, if it is equal to 90 or more than 90 degrees. Vice versa in the southern latitude. For the sun not to be visible, it is you are in the northern hemisphere, but sun declination is south, but when added up, it is again greater than 90. Hence, rising and setting of the sun depends on the ship's latitude and sun declination. Some of it should always be less than 90 degrees. Now let's look at the gyro error, having understood the theory behind the declination relationship with the ship's latitude. We have to know about what is visible sunrise, visible sunset. That is, what is visible, the sun which is visible above your horizon is called visible sunrise. However, at this time, the sun altitude will not be 0. When the sun is at the celestial horizon, which is at 90 degrees from your zenith, it is called theoretical sunrise or theoretical sunset, which occur when the true sun center is on the observer's celestial horizon. Since the true altitude is 0, the zenith distance is also 90 degree. Now we can use PZX classical spherical triangle where the side is ZX is 90 degree. So it is the quadrantal spherical triangle we can resolve it. In the visible sunrise, as I told you, the true altitude will be in below the celestial horizon. That is 0 degree 50 minutes below the horizon, celestial horizon. The zenith distance is not 90 degree, it is 90 degree 50 minutes. Nautical almanac, it talks about local mean time or ship mean time of visible sunrise and sunset. And we have to convert it to theoretical sunrise and sunset. Now this is a picture to depict why visible sunrise and sunset is not useful for us. That is, when the actual sun is what is visible to your eye, which is about 1 semi-diameter above the horizon, at this time, true sun is at the celestial horizon. It is caused by the maximum refraction of atmosphere is about 34 minutes on the horizon and sun's angular distance, the semi-diameter. Now, this is to show a picture about the refraction. You can see actual position of the sun, how the refracted ray is showing the image of the sun, refracted image. Now, this is a gyro equipment. We are not here to learn about the principles of the gyro, but we are going to ascertain whether the gyro is working as per the functionality. Now, this is another picture of the gyro repeater and also azimuth circle to aid you to observe the bearing of any object, in particular, in this case, sun. There is another picture for you to appreciate. The azimuth circle and the rising sun can be looked through the crosshair exactly and observe the rising azimuth. Now, as I said earlier, with the zenith distance is 90 degree during the theoretical sunrise or sunset, using the quadrantal spherical triangle principles, and we can use the Napier rule to resolve it, and we can obtain the rising azimuth or setting azimuth by following the formula. That is cos of rising setting azimuth, which is equal to sine declination divided by cos lat. The angle between the true north and the vertical circle of the sun at that time. What is the gyro error then? You have observed through your gyro repeater from the bridge wing or from the bridge or bridge top. And also you have calculated the visible sunrise or sunset for the day and worked out the declination of the sun on that day. From the formula, you have calculated the rising azimuth. Simultaneously, you have also observed. When you compare both the bearing, if the observed bearing is more, then your gyro is reading high. When the observed bearing is less, gyro is reading low. It is always to remember, not only knowing the gyro error, you have to apply it for future courses to be steered by the ship. It is a practical tip for you. If the error of the gyro is high, always steer high. For example, you have 10 degree high error. You want to achieve the ship course of 0, 0, 0. Then steer 0, 1, 0. That is the course to order 12 man. If error is low, always steer low. In this case, if the error is 10 degree low, then you steer 350 by compass to achieve the true course of 0, 0, 0. Another terminology is amplitude. Amplitude is nothing but a complementary angle to rising or setting azimuth. As shown on the picture, amplitude is 90 degree minus rising setting azimuth. Or in other words, rising setting azimuth is equal to 90 minus amplitude. Hence, the formula can be rewritten using the sine amplitude equal to sine declination and cos lat. I hope this particular instruction is very useful for you so that you can observe this gyro error, and it is normally done every day in the morning with the sunrise and in the evening with the sunset, so that the captain and the bridge team are at peace and they have ascertained the correct functionality of the gyro equipment, the direction device, especially for ocean going ship. Best of luck. Thank you.